Good morning, grade 11 students. This is Mrs. Pascal. Today's date is March 12, 2020. Our lesson is Chapter 4, Section 4.2, the standard form of a quadratic function. The objective of this section is to identify the features of a quadratic function in standard form, and we will examine the connection between the standard and the vertex form functions. What are the features of a quadratic function in standard form? The features or characteristics of a quadratic function in standard form are the axis of symmetry, which is the vertical line of equation x equal minus b over 2a, the vertex of coordinates x equal minus b over 2a, the same value of x of the axis of symmetry, since the vertex is always a point on the axis of symmetry, and with ordinate y equal f of minus b over 2a. In order to calculate the ordinate of the vertex, we need to replace the abscissa of the vertex in the given function. Type of the vertex. The type of the vertex determine whether the graph of the function opens upward or downward. It depends on the sign of A. If A is positive, the vertex is a minimum point. It means that the vertex is the lowest point of the graph and the graph opens upward. If A is negative, the vertex is maximum point. It means that the vertex is the highest point of the graph and the graph opens downward. The range. The range of a function is a set of values of y that verifies this function. So when A is positive, then the graph opens upward. So we have a minimum point. That's why the range of this function is defined by y greater than or equal f of minus b over 2a. When a is negative, then we have a maximum point and the graph opens downward. So the range is defined by y smaller than or equal to f of minus b over 2a. The y-intercept is the point of intersection between the graph and the y-axis. It's always defined by x equal to 0, y equal to c. Let's take the first example. Identify the features of the function f of x equal x squared plus 2x plus 1. Start by identifying the real values of a, b, and c. In this function, a is 1, b is 2, c is 1. The axis of symmetry, which is defined by x equal minus b over 2a, is equal to minus 1. The coordinates of the vertex are minus 1, 0. Remember that to obtain the ordinate of the vertex, we need to replace minus 1 in the value of x of the function. Since a is 1, so the vertex type is minimum, and the graph opens upward. The minimum value of the graph is 0, so the range starts from 0 and above, so y is greater than or equal to 0. The point of intersection between the graph and the y-axis is 0, 1. How can we convert from standard to vertex form? To convert from the standard form f of x equal ax squared plus bx plus c to a vertex form f of x is equal a into x minus h squared plus k, where h and k represent the coordinates of the vertex of the same function, all we need to do is to find the vertex from the standard form and use it in the vertex form. Example 2. Write in vertex form the function f of x equal x squared minus 4x plus 6. So all we need to do is to find the vertex from this equation or function. Define the values a, b, and c. A is 1, b is -4, c is 6. The abscissa of the vertex is minus b over 2a, which is 2. And the ordinate of the vertex is 2. So the vertex is defined by the coordinates 2, 2. To write the vertex form, use the formula f of x equal a into x minus h squared plus k and replace by the values of a, h, and k. A is 1, h is 2, k is 2. Finally, we get f of x equal 1 into x minus 2 squared plus 2. This is another example. Write the function f of x equal minus x squared plus 3x minus 1 in vertex form. So determine the values of a, b, and c. A is -1, b is equal to 3, c is -1. Find the coordinates of the vertex. The coordinates of the vertex are x equal 3 over 2 and y equal 5 over 4. And finally, we write the vertex form f of x equal a into x minus h squared plus k. So we replace a by -1, h by 3 over 2, and k by 5 over 4 to get f of x equal -1 into x minus 3 over 2 squared plus 5 over 4. Finally, to convert from vertex form to standard form, we need only to expand and reduce the function. Example, if f of x is equal to x minus 1 squared plus 2, use the remarkable identity rule in the form of a minus b squared to expand this function, and we get finally the standard form f of x equal x squared minus 2x plus 3.